All right, I think we can proceed. Yeah. All right. Good afternoon, everyone. Warm welcome. Thank you so much for attending the session today. This is a live webinar with the topic of introduction to mini drone competition. So my name is Kuni. I'm from TechSource, and today joining me will be my colleague Yen. So I'm I'm the account manager responsible for managing the education sector in Singapore, covering all the universities, polytechnics, and other education institutions. Ian is actually our application engineer. So basically, I will provide you with the overview information about the competition, and Ian will actually follow up with the details. All right. So let's move on. All right, just a quick reminder, just to get this session moving very smoothly. Kindly turn off your cameras, mute your microphones. And as mentioned, this session is actually recorded. And the recorded session, as well as the materials, PDF materials of this presentation, will be emailed to you on the emails that you have indicated in the registration. All right. So please do share the information with some of your friends who might not be able to attend. All right. It's also there's if you have any questions at any moment, just put in the chat box, and someone will actually attend to you immediately. All right. So just don't be shy. Any questions is a good question for us. All right. It's for everyone to learn as well. All right. So let me first introduce to you TechSource. So like I said, I'm from TechSource. Ian is from TechSource. We are the authorized reseller for MathWorks in Southeast Asia. All right. MathWorks being the developer of MATLAB and Simulink products. The products that essentially you're going to use in this mini drone. We represent MathWorks in several countries. We have in Singapore, Malaysia, Thailand, Indonesia, Philippines, and Vietnam. All right, so we have these countries that we are representing for MathWorks. In case for those of you who are not very familiar, never heard of MathWorks, just a quick information for you. MathWorks software is actually used in various areas of products that's being designed throughout the industries today, from automobiles, commercial aircraft, smartphones, consumer goods. Essentially, any electronic products that you see out there will have MathWorks footprint. All right, so some of the breakthroughs that MathWorks is involved includes the areas like space exploration, advanced prosthetics, autonomous robots, and even clean renewable energy. A lot of work is being done in this area, assisting scientists and engineers in their fields. All right. So we were talking about MATLAB. Let me just give you a quick, explanation of what MATLAB is. MATLAB is a programming environment for algorithm development, data analysis, visualization, and numeric computation. We will also be talking about Simulink. Simulink is a graphical environment for designing, simulating, and testing systems. So these products, right, are actually supported by hundreds of toolboxes, which are very, very specialized for different workflows, right? From image processing to robotics to UAVs and everything else that you can think of. Basically, there are 100 over toolboxes that support every workflow there is. Our customer base, all right, as you can see, is very huge. We have about we're talking worldwide, not ASEAN, all right? Worldwide, MathWorks has got a total customer base of 5 million, spanning across 190 countries, including more than 100,000 businesses, governments, and universities. By the way, especially for universities, since I'm actually involved in this, pleased to inform you that our public universities like NUS, NTU, SUTD, SIT, and most of the polytechnics are already using MathWorks, MATLAB and Simulink. Some of them, like NUS, NTU, SIT, and SUTD, they have acquired the campus-wide license. That provides unlimited access to everyone in the campus. On top of that, all the top 10 automotive and aerospace companies around the world uses MATLAB and Simulink one way or another. So this is how entrenched MathWorks the involvement in the industries are today, right? And just to give you a feel of like the breadth and the scope, this is a cross-section of the industries that MathWorks is involved, from aerospace to biological sciences, electronics, industrial machinery, semiconductor, railway systems, communications, and many more, right? As you can see, it covers essentially every aspect of the industry. Now, let's go to the main topic we are here to discuss, MathWorks Minidrone competition. Right. Very, very pleased to inform you that this is the first MathWorks Minidrone competition to be held in Southeast Asia. And it is co-hosted by the School of Mechanical and Aerospace Engineering and Intelligent Cybernetics Group at NTU. Right. So they are hosting this event. And we are also pleased to inform you that there are exciting prizes to be won, or cash prizes to be won. And they too are being sponsored by NTU. Speaking about prizes, right? First prize, there's $1,000, all right, worth of, I mean, it is cash. Second prize is $500 cash, and third prize, $250 cash. By the way, the cash amount is provided to the winning team, not to each person, but to the winning team. All right. So generally speaking, the mini drone involves two specific rounds, right? The first round is a virtual stage of it where you create the simulation and you submit the simulation to MathWorks. MathWorks will then review all the entries, and it will shortlist certain numbers of finalists. And the finalists will then proceed to the actual final round, where they will then have the opportunity to deploy the codes to the drone, so they will be able to actually handle the drone and fly the drone. And that will be the final round, right? Just to give you a sense of like what the activities involved in this competition. So we are now, registration for this competition, as you know, is open, and it is going to close very soon, 6th April. So we urge you to quickly set up your teams and register quickly. And also please do share this with your friends who might be interested as well. As I mentioned, the first part of it is actually the virtual part, right? So there is a simulation submission. So you submit the codes and everything, and the date of the submission is on the 25th of April. The shortlisted teams will be informed on the 10th of May. So they will announce the shortlisted teams that will then go through the final round. The final round is actually on the 11th of June, all right, will be held in NTU premises. But there is a practice round on the day before, which is on the 10th, all right, so where teams will be given chance to familiarize themselves with a drone, so they can actually deploy the codes and give it a try, so that they're more familiar with it and they'll be better prepared for the final round. So essentially, this is how the competition looks like. I will pass now to my colleague Ian, who will then deep dive into various aspects of the competition. So again, just to remind you, if you have any questions, please feel free to just put in the chat, right? So we will able to answer any of your questions. All right, then over to you, Ian.
Yeah, thanks a lot, Kuni. Yeah, so for today, Kuni already went through a lot of the competition details or the admin matters. So what I'll go through now is more of the technical details behind the competition, like what are the information or resources that are available to you to actually assist you with this mini drone challenge. Yeah, so today this is just a short agenda of what I'll cover, just talking a little bit about the drone or quadcopter, its dynamics, and how to replicate and control the drone within Simulink itself. So if anyone here is familiar with drones already, it might be a bit of repetition for you, but I hope that everybody can take away something new from today's short lecture. Yeah, so before we dive straight in, let's just go through some of the key details which Kudi has mentioned. I think one thing he forgot to mention was that each team has to be within either 2 to 4 members. Yeah, and there'll be a simulation and physical finals. And don't worry, we'll be reiterating these competition deadlines as well towards the end of the lecture. But I think in chat as well, I just put up the actual web page that you can go and check it out right after we finish this lecture. So what exactly is MATLAB Simulink? So MATLAB is a programming environment very similar to Python, a high-level programming software for algorithm development, data analysis, visualization, and numeric computation. Meanwhile, Simulink is more of a graphical environment that allows engineers to design, simulate, and test systems before moving on to the actual hardware itself. And like Kuni mentioned, we have over 100 additional toolboxes for specialized tasks such as data analysis, image processing, and computer vision. And the tools are used to design, simulate, and test many of the products we rely on every day. The car that you drive, the plane you'll fly for your next big holiday, and the smartphone you can't live without, even your washing machine as well. And so now let's just take a look at a real-world example of how MATLAB Simulink was used. So this is an example of Blue Origin. They basically is a company that are building reusable rockets that will take private passengers into space. And in December 2015, they made history as the first rocket to go into space and do a vertical soft landing on return to Earth. So here's just a very short video. So what is happening here is the rocket launching, entering space, and safely landing back on Earth after around 7.5 minutes of flight time in the air. And our tools were used to design the control systems that allow the rocket to land back vertically without actually just falling back onto the ocean itself. Yeah, so now just some basics of a quadcopter or drone. So can anybody throw out a quick guess of how a quadcopter is defined? So is there any distinction between the widely available and well-known drones like DJI and a quadcopter? Yeah. Yeah, so basically a drone is a uncrewed vehicle that is guided by remote control or onboard computers. And meanwhile, a quadcopter, as the name suggests, from the quad part, is a more specific term for a flying drone that has four or more rotating propellers. So essentially, a quadcopter is a subset of drones, but people use the terms pretty interchangeably in a more common setting. So now let's say if a rotorcraft would have 6 rotors, it would actually be called a hexacopter and so on and so forth. And these rotors to which the four propellers or the fans are connected to helps it generate lift and move around. So what is the actual drone that you'll be working on with the simulation part and the finals, physical finals? It is actually the Parrot Mambo mini drone. It's an off-the-shelf drone, and this will be our hardware of interest throughout this competition. Like every other typical robotic system, the Parrot mini drone has sensors to help it perceive the physical world around it, gathering data and information for it to perform the calculations needed. And after processing all the incoming information, it can then interact with the world with its actuators, which is these rotors. And in some cases, we will actually assemble a drone from scratch, and we are able to connect and customize various sensors and motors for our drone. But we'll not be doing that here as it's a little bit more complicated, but instead, we are using this off-the-shelf hardware, which is a complete working package that's inbuilt sensors and motors that we will control. Now let's dive into the specifics of the Parrot mini drone, which may not seem like it's too special, but the whole package does allow it to achieve semi-autonomous flight. So we briefly covered how sensors are how robots receive information about the world around it. So what are the sensors that the mini drone has? It has, first of all, it's an ultrasonic sensor that will calculate its distance from the ground below, and a camera that can see the overhead view, as well as calculate the velocities at which the drone moves. And there's also a pressure sensor that is used to double check the height based on air pressure. And finally, a IMU with a 3-axis accelerometer and gyroscope. And this is something that's present in all our phones, and it is actually what enables navigation apps like Google Maps to accurately track our location. Now that we're done with the sensors, let's talk about the actuators itself. For our mini drone, we have 4 motors, and these are the ones that control how the drone moves around within 3D space. And we will send some values to the motor, and it will start hovering or going left, right, up, down, depending on what the value is. You must also understand the configuration of the drone if you want to understand the movement of how the drone moves. And there are various configurations, but I will be going through the 2 most common configurations of a quadcopter today. And the first one is called the X configuration, because it looks like an X. And here, the mouth of the drone faces the empty space within the middle of the lines that are coming out from the X. And you also have the plus configuration, where the mouth of the drone faces one of the arms instead. And the major difference between the two is what commands you give to the motors, but essentially the type of movements that can be achieved is very similar. Yeah, so here we have just some equations of motions, not really too important, but basically just saying how the dynamics of a drone will work. But using the previously shown equations of motions, we essentially want to achieve these 6 movements or degrees of freedom: up and down, left and right, forward and back, and finally rotation around the X, Y, and Z axis. But the actual movements that we will directly control with our phones or the sensors will be the thrust, pitch, roll, and yaw. And here are the 4 examples or simple representations of how each of these 4 movements are achieved using the hardware on a typical quadcopter, basically by varying how much force each motor is given. So thrust helps to achieve vertical takeoff and landing, and yaw enables a rotation in the z-axis, and roll and pitch are a combination of rotation and translation in either the x or y direction. So using these combination of 4 movements, we can achieve the 6 degrees of freedom that a quadcopter needs to freely move from one spot to another. And now that we understand some of these basics of drones, let's get into how we can actually model a drone within MATLAB and Simulink. But first, let's talk about how do we actually control a drone from human's perspective. Let's begin with a simple example of us controlling a toy drone using a remote, which is on our mobile. We can control the location of the drone in the space by providing the 4 commands that we initially talked about: thrust, pitch, roll, and yaw. And how do we control it? Well, first, we need to observe with our eyes the current location of the drone. And if we need to move more to the right, we ask it to go right. And we are the ones that provide the commands to the drone depending on what we see. So essentially, we are the controller in this process. So we perform this whole process intuitively, as we have learned how to distinguish between a drone and its surroundings and determine the path where we want it to go and provide the eventual controls to follow the path. However, if we wish for a computer to do the same thing by itself and adapt to different kinds of paths, it becomes a lot more complicated. So where do we even begin translating how we think into the concrete commands that the computer understands? And this is where the process of model-based design comes into play. Now, let's say we have a real-world system. The reason why simulations are so important is because we get to try the logic where we are designing before we actually run it on the actual system or our actual hardware. Because we do not want our robots, be it land or aerial, to be planning to move to the right when we want it to move to the left when there's a wall on our right. So this is where simulations help a lot. We get to try our design logic before we actually start working on the hardware itself. And as students participating in competitions, we are designing systems like this on a much, much smaller scale. And considering we would all like to step in this industry in the future, learning the value of simulations at the start is very beneficial. And that is why we have this challenge to help you learn by having fun during the mini drone competition itself. So the most important principle to understand in order to build accurate simulations is model-based design. And we describe model-based design as the systematic use of models throughout the development process, which has 2 major components: modeling and automation. Modeling covers the simulation analysis aspect, which allow you to try out new ideas and give you fast and repeatable tests. While automation covers the coding and verification aspect to take out manual steps and reduce human error. And this enables shorter and agile iteration cycles and saves time and money spent on the project and ensures the delivery of an end product with minimal defects and high quality. This is because traditional development processes involve heavy investments in building physical prototypes, which is very expensive, time-consuming, and prevents rapid iterations. On the other hand, creating and simulating a virtual model enables complex design, space exploration, and continuous design improvement, which is much cheaper, faster, and safer. However, the spending on simulation has been relatively low, and we can balance this out by reducing waste from creating physical prototypes and placing a stronger emphasis on modeling and simulation, which enables you to spin your development cycles faster by rapidly prototyping and testing new ideas. And Simulink is the ideal platform for model-based design, which is basically a block diagram approach to modeling systems that can automatically generate code. And this is majorly used in a lot of control systems, signal processing, and aerospace-related applications. So now for how to model a drone within Simulink itself, you know that the four motor speeds that's given to us, to our drone, causes the drone to move to a specific location. And we also know that we get the values from sensors, which can then tell us what location our drone is currently at. Now, let's say we give the drone coordinates for a new location we want to move to. The only thing we have missing here is an algorithm that can calculate the motor speeds from the error between the desired location and the location communicated by sensors. And this is what we call the controller. The controller will be the one that will calculate the motor speeds for us, that will manipulate the drone to maneuver 3D space. And this can be achieved using Simulink, and the final implementation will look something like how we see in this block diagram itself. This may look a bit daunting and complicated at first, but not to worry, we'll be providing you all the resources required to be able to understand and edit this model to provide it to make your own drone algorithm for the competition itself. But just to give a brief overview of the parts of the model, first we have the section that includes the plant and the sensors on it, basically a simulated representation of the physical drone hardware. And we also have a visualization environment to help us see where the drone is within a simulated 3D space. And finally, we also have a really controller that we can use to hover the drone and control its various movements. And this is the main bulk of the model that you'll be concerning yourselves with. And now moving on to a quick overview of the SSPM or Simulink support package for Parrot mini drones, which is one of the main resources you will tap into for the competition itself. Since MATLAB and Simulink are general products meant for use with a wide variety of applications, it's not feasible to include all the support for different kinds of hardware like Arduino, RPi, NVIDIA Jetson within the base installation itself. And this is why we have additional support packages, which are free to download anytime from the Add-on Explorer, as long as you have a valid internet connection. And this enables users to pick and choose which support packages to download based on the hardware that they are working with, and at the same time preventing the base installation to be too bloated. And the Simulink support package for Parrot mini drones is where you can find all the documentation needed to find more information about the blocks that we use throughout the competition. And there are also some default examples that you can explore for further learning. So once you download the support package, there'll be a default example provided that already has a simple closed loop algorithm for you to control the drone. However, this current algorithm provided is very rough. And basically the essence of this competition is how can we make this algorithm better? How can we make the drone follow the entire track instead of moving a set distance and checking for the track again? And this is the challenge posed to you for the competition to optimize both the perception and path planning segments of the model. Of course, we do not want to leave you completely in the dark, so there are definitely tools provided that enable you to build and test your iterations of the algorithm before the submission of the simulation phase. And once again, here are the key deadlines to take note of for the competition. And now let me just go through the sign up page and some additional resources that you can actually have access to. So let me just open the link itself. Yeah, so here we can see the landing page of the competition, and here are all the deadlines, and here are the bare minimum resources to go through. So we do have a video series to watch, all very short 5 to 7 minute videos, as well as some on-ramps. But do take note, even though these are the bare minimums, there is one more on-ramp on the slides itself that I'll show you later on. And so on the slides itself, there's also additionally a image processing on-ramp that is highly recommended to actually go through itself. Yeah. So image processing on-ramp on top of the 3 on-ramps stated on the competition page itself. Yeah. Additionally, on the slide hyperlink, you'll also have access to a more in-depth webinar series. So this is actually hosted by another institution, but basically here are the recordings for basically 1 hour versions of these series, short 5 to 7 minute series. So these are more in-depth, not really necessary, but if you do wish to learn more about drones and how they work in Simulink, you can definitely take a look at these recordings itself. Yeah, so that will be it for these presentations. So if you have any Q&A, please drop in the chat and we'll be more than happy to answer any questions. Or if you have any questions after this session is ended, you can always drop us an email at this the email shown on screen now with the subject line query support MathWorks Singapore 2024 challenge and with your team number. And this is only after you've actually signed up for the competition itself. Yeah, so I do see that there is a question. Is there help to learn MATLAB? Yeah, my colleague Yanni has actually answered that. So there are a plethora of resources available to you, which I just shown to actually help you get started on your MathWorks and Simlink learning journey.
Well, I'm also pleased to inform you that we have our colleague from MathWorks, Naini, joining us today. So if you have any specific questions that specific to MathWorks, right? She's standing by, right? So feel free to just ask any question. There is a question about the judging criteria.
Yeah, so for the judging criteria, it's basically for the simulation phase, it will be because you know how, if I zoom back on the slides, you know how we provide you a tool to actually test your drone on different algorithms? It will basically be a random path that your drone will have to follow. And we will see how effective each of your drones will actually follow the random path that is selected by MathWorks themselves. So that is the judging criteria for the simulation part. And actually for the finals, it's very similar. There'll be a random path that you do not know beforehand. And then you just need to basically achieve the best path following algorithm.
There's a question from Benjamin Ma. Is it a must that we need to use Parrot mini drone? How about other mini drone such as DJI?
Yeah, so for this particular challenge, you will only be provided the mini drone because you know how each drone has its own firmware and actually how you actually control each drone varies slightly from drone to drone. So this specific challenge is only for the Parrot mini drone, and because all the resources are provided to you already, so there's actually not too much work in terms of new stuff you have to come up with, but it's really only the control algorithm and the perception where you actually have to make sure that you can single out this red line from the camera feed of the drone itself. Oh no, you will not have to buy your own Parrot drone. So everything in the simulation phase will be on MATLAB and Simlink itself. And for the finals round, the mini drone will be provided to you already to actually test your simulation algorithms. And then finally, on the 11th of June, like Kuni mentioned, will be the actual date of the finals round. And I think Kuni, there's also a question by June of if they'll be able to get software licenses. Sorry, Kuni, you're muted.
Good question, June. So if you are from any of our universities, any of our public universities, you are already on the campus-wide license, so you'll be able to access the software on your own. But if you are from an institution that do not have MATLAB, I think the resources provided in this competition does include the software license as well, all right, to equip you for the competition, right? So June, by the way, if you can identify perhaps which institution you are from, I can advise you immediately. Singapore Poly, right? I suppose. Okay, for polytechnics, yes. Okay, so for polytechnics, at the moment you do not have the campus-wide license as yet. So not to worry. Once you sign on with this competition, you get access to the licenses for the duration of the competition. Hope that answers your question.
And don't worry if you couldn't catch any of the links that I mentioned earlier, because the full slides will be sent to you within 48 hours after the conclusion of this session. Yeah.
Each one license or each one to get a license or the team to get one license? Ian, do you have an answer to this? If not, we can ask Naini is standing by. So because it's also our first time, organizing this event, so there will definitely be some areas that we need more information from MathWorks. So Naini, if you're there, would you like to answer this question?
Hi, Kuni. Thanks for this question, June. I believe that it's each and every team member that will get the license. But while they're on the call, I'm also confirming this information with one of my colleagues. So he's just responding to me now. I'll get back to you in 1 minute on that.
I think not to worry, right? Because I think on our part, we will be able to support you with any temporary licenses that's required, during this period of competition. So that there should not be any issues of not being able to access licenses, all right? Please keep the questions coming. These are very, very useful questions that, help everyone to understand the event better.
So I have the response from my team. They say that the team captain, the one who will register for the competition, will get the license directly, but the team captain can share the license with the entire team.
Okay, there you go. All right.
So you will have access to the license.
Yeah, so every member will be able to access the license. How many teams are we competing? Well, the competition registration is still very much open, June. So we haven't gotten the final numbers yet. So it's still coming in. Yeah. So anyway, as you know, right, there are two phases to this competition. The first part will be the simulation part. So that's where the first challenge will be. And only shortlisted teams were able to qualify for the next round. All right. So I think the number of teams that participate doesn't really matter at this stage. Yeah, for simulation stage at least. I do hope there will be a lot of students from the polytechnics joining us as well in this competition. Any other questions?
Also, just for the information, can we also add the details about, since we have the cash prize and the certificate and there's a trophy as well, maybe if it's possible to just show the winner circle page for the participants here. If we hope that you register for this event and that you win the competition as well. We do have something called as winner circle on MathWorks, where we will actually be also showcasing your victory in this particular competition as a published story on the website. So that's an additional incentive that you will also get.
Okay, let me bring up the link.
This is a good point Naini brought up, right? Because MathWorks organizes competition worldwide, right? So the winners get their, in a way, the projects being highlighted across institutions around the world.
I've also added the link in chat just in case.
Okay, yeah. Great. Yep. Yeah, I couldn't find it, the link. Okay, yeah. So here's the winner circle that Niani was mentioning. So you can see there's previous Minidrone competitions that were hosted as well. And yeah, so automotive, robotics.
This is for every competition, but there's a specific one for Minidrone as well.
Yes.
Naini has provided the link there in the chat.
This is the winner circle which I provided.
Yeah.
But there is, even if they win the competition for Minidrone competition, the same would be having a winner circle for that.
Also a separate category, correct?
Yes.
Yeah. Oh yes, Benjamin Ma. So Benjamin Ma asked, so for the parent Minidrone, is there a system model already available? Yeah, so what you see here is what's provided to you. So with a very basic, so there's basically no, you do not start from scratch. So, but what you actually do is to actually edit this controller portion, where you actually have to change you probably have, no, I mean, you don't have to change, but you have to optimize the image processing part, because currently on the default model, what you get is a algorithm that follows a blue line, I think, a blue line, and that's all it does. Like, I mean, it detects a blue line and then it moves a set distance. Then after that, it will just stop. So it's a very simple algorithm, closed loop algorithm. And additionally, so what you have to do is actually change your image processing algorithm to actually detect a red line and also optimize it such that it's able to navigate around like sharp bends and different kind of environments as well. So yeah, you are not starting from scratch. This is the actual model that is provided to you. And you can actually see all these details within the landing page itself. Yeah. And in fact, you can even peruse the support package even before, if you have a campus-wide license, you can actually peruse the support package and take a look even before registration as well.
June is asking if the winner will have a chance to compete internationally in the future. Naini, what's your answer to that? Is there a global challenge?
So far, the competition by MathWorks, this MathWorks Minidrone competition is very much using the similar problem statement. And, so far we have not yet leveraged all the winners and invited them to be a part of a global competition, because the problem statement will remain the same, right? But the good thing would be that if you win the competition, the winners also become a part of the MathWorks Minidrone competition winner circle. So the winner circle is a separate group which has been created with all the winners of this participant. You can join that group. And for other competitions, we can, of course, there would be other details that we shared with you. But as of now, just to give you a quick answer, we don't have a competition where the winners have, participated again. But there are other competition that MathWorks does sponsor, and we can definitely share resources with you, and you can still participate in that.
June is asking again, another question from June. Will there be a pre-event workshop?
So pre-event, we are doing another webinar, right? June, to answer your question, today was like a promotion webinar that we wanted to, introduce you to the competition itself. Once you have registered, with all the registered participants, we will be doing a technical ask us anything type of a webinar, where once you have gone through all the MATLAB Simulink models that we have shared with you, once you have started to work on the problem statement, you can ask the engineer from MathWorks directly if you have any technical questions, and they will be answering that. So there's no workshop, but there will be a webinar where you can ask technical questions to the MathWorks engineer directly. That's one thing. Another thing is, as Ian already has shared the link on video series, so that covers mostly a lot of technical details which are required for the competition as well.
Yep, this is from the MathWorks Minidrone. So once again, if we go back to the main page of the MathWorks Minidrone, so you can see here the video competition series. These are the base videos that you will actually get 5 to 7 minutes. All you need to know, like the bare bones. But there is also, within our slides itself that we shared today, there will be a more comprehensive 1 hour recordings here. So if I just click to one, you can see that it's a unlisted. Oh, sorry. Let's get through this ad. And you can see there's an unlisted video. They can only access the link, and it's about a 1 hour more in-depth video series on the dynamics of the drone itself. Yeah. But all you need is actually these 5 minutes videos. That's all.
And there's just to add on, there's also the on-ramp online courses, self-paced courses that Ian has mentioned earlier that you can access anytime, right? Just to build up your fundamentals in MATLAB, Simulink, and some of the other related areas. So here you go. So this is your at your own time, all right? It's self-paced. So state flow, right? Simulink state flow will be some of the core. Yeah, image processing. I think we have listed down, right? We have listed down in this. Sorry, Ian, you are muted.
Yeah, image processing isn't listed on the Minidrone landing page itself, but it's highly recommended because it will pertain to the perception portion. Yeah. Yeah, so this is an extra material that is highly recommended, but it's not necessary. Yeah, because it's not listed here.
Anyway, all the on-ramps that is listed is accessible to everybody. All right, so beyond this, please feel free to pick up any of the on-ramp packages there.
I added one more link in the chat. It's a blog by the winners itself. So that blog shares how to win this competition. So if you're also, interested to go through this blog and hear directly from the winners, their best practices, how they managed to win the competition, so you can also go through this.
Okay, thanks, Nani. I'll add this as a hyperlink in one of the last few slides that you can browse after this session's over as well.
Yeah. So there are two blogs. One I have shared already, and there's one more which I'm adding to the chat. So don't worry, these links will be added to the slides that Ian has, and these will be directly shared with you.
Yeah, thanks, Nani.
Hi everyone. Does anybody else have any other questions? If not, you can contact us or MathWorks for any questions that you have. Oh, we have one from Jun Fang. Can you add image processing on RAM 2 in the slide? Yes, we can add on.
Yeah, actually,
the
image
link.
processing is recommended on the slide itself already. Correct. It's just not on the web page itself.
I also have one more request before we end this session. Since very limited students could join, I would also request you to, share this information with your friends. And you are already aware of the timeline for competition. So the deadline for application is 6th April. Please invite as many friends as you can. This will be a good challenge. It will be a good experience for you all. As Kuni mentioned initially, MathWorks is doing this competition for the first time, not only in Singapore, but in Southeast Asia. So this gives you a good opportunity to be a part of, the global MathWorks student competition team as well. So please feel free to share this with your friends and ask them to participate as well.
Thanks, Nani. And so if there's no other further question, I think we can end already. But if you do have questions along the way, please do email us at the email that Ian has shared just now. Anyway, we will be sending all the recording and the presentation that we've done right now. We will send it to you via your emails, all right? And we can follow up thereafter. Cool? All right then. Thank you so much, everyone, for attending this webinar. Have a nice day.
Yeah.
Bye-bye.
Thanks, everyone. Goodbye.